just as we did with z-scores, it's time for us to put this all together, everything we've learned, to be able to find x values in a little bit of a puzzle like this, where not everything's equal and symmetric. Okay, so we were given the central area this time, and this x value over here. So we're going to be looking for, I'll call this area 1, this is area 2, this is area 3, and this is x1 and x2. All right, well, let's think here. If we know this x value, we definitely could find area 3, right? Because they're tied to each other. I think we're in a little bit of trouble. I don't think we can find either of these values yet. I think we're going to have to go with area 3 first, because we can't find area 1 until we found area 3, and we can't find this x value for certain until we know what area 1 or area 3 is. All right, so let's start with area 3. So area 3, so let's think. We know an x value. We want to find an area. So we want to find an area from an x value. This is the one. We're doing number 3. Right? We're going to put in our mu and our sigma. We're going to put our x value in, and we're going to make it find the area. Remember that it's not always less thans. Those symbols I can't put in all the possibilities for those symbols. So you have to know which one to pick. All right, so let me make this smaller here. All right, so, and again, I'll just reiterate what we do. Stat, calculators, normal. So you're going to tell it that the mean was, in this case, 250, and the standard deviation was 25. Lovely. And then we're going to tell it a greater than, and then we want to tell it greater than 272.4. And there we have it. And it matches it, right? I mean, it looks like what that looks like on there. So now let me write this out. So the probability that x is greater than or equal to 272.4 equals 0.18. I only wanted 3 decimal places, so 0.185. So this right here is our answer. That's the area. Right there. Okay, now what about this middle area? Well, we know the middle area here, so we can find area 1 now. Area 1 is actually pretty easy, right? Because area 1 has to be, if you take 1 and take away the 2 areas we know the middle area is 0.766, and then we also take away that area we just found, which was 0.185. We'll have what's left over for area 1. And this is where Desmos is useful. All right, Desmos, give me a number. 1 take away 0.766, take away 0.185. So take both of those pieces away from 1, and I have 0.049. So that's area 1. I can label it right here, 0.049. Easy peasy. All right, so the last bit, the x. Okay, well, if I want to find an x, let's look here. The way x values work, let me make this bigger so you can see it better, sorry. When you want to find the x value from an area, that's what we're trying to do. We know the area. We know the area to the left or to the right, either one. And we're looking for the x value. We're going to do this. All right, put the area. Remember, area always goes in over to the right. So, and you technically could do this area here or these two combined, but let's face it, you're going to do this one, 0.049. Okay, so let me go back to StatCrunch. I'm going to tell it my area is 0.049. Too many. Oops, there we go, 0.049. There we have it. Uh-oh. Oh no, that doesn't look right. I did it on purpose. What happened was I didn't switch my sign. So it's 0.049, but I need to go to the left. But if I go left now, oh no, that's even worse, right? So just retype it. Retype it, the area over here, put in the less than, and click compute. And then that looks like what we want. And we can see the answer is 208.63. So let me write it down here. So the probability that x is less than or equal to 208.63, 64, we want 3 decimal places, equals 0.049. 0.049 is not the answer. The answer is that 208.63. Right, that's the answer. That's this number right there. Again, that was how to do it with StatCrunch. If you're working with StatCrunch, then you can just skip ahead to the next video. I'm going to show how to do it with the TI-84 for those folks that are using that. All right, TI-84 folks. So let's think here. First bit was part 3, right? We wanted to find an area given an x value, and that's using Normalcdf, right? So we would go to Normalcdf. Normalcdf never changes. Old calculators, new calculators, it's all the same. So if I want to do Normalcdf from 272.4, that's the lower boundary, right? The lower, 272.4. The upper is 1e99, to take the place of infinity. And I put 250. There we go. And then the standard deviation is 25. Paste. Enter. And there we have it. 0.185. Same thing they got. There it is. All right, so that's easy. And then the middle part, or the portion where you find the area is no big deal because, that's just as easy here as it is anywhere. So that's easy. Then the hard part is, of course, the inverse norm. So inverse norm, you hit second distribution, number 3. You tell it the area is 0.049. Oops, 049, get that right. The standard deviation, or the mean was 250. The standard deviation was 25. And you have to tell it left. And then press paste and press enter. On the old calculators, it's actually automatically left. There is no other option. So you go to second distribution, inverse norm, and you would tell it 0.049, 250, 25, paste, enter. So there you have it. So you'll get the same answers they had, but it'll just take you a little bit more work.